Okay, so it's 6-2. This is video 115. And as I said this morning, that this example over here on the right hand side over here is a more complicated example, and I really wouldn't be doing my job if I didn't do this one here to show you that the great majority of division problems in polynomial have a remainder. So I'm going to get a remainder in this case, and you guys can see how that's naturally going to happen. So we said that we don't consider polynomials with a remainder because we excluded polynomials where x is negative. The exponent of x is negative, that is, it's on the bottom fraction in the denominator. But I'll show you anyway because it does exist, and I'll work out the problem completely. So here we go, like what we did yesterday. X goes into x squared x times. Okay, so you see me doing that. X times x is x squared. X times 1 is x, and subtract. So far, so good. 4x plus 2, because I bring down the 2. So I think everybody sees what I'm doing. Well, x goes into 4x positive 4 times. Check. 4 times x is 4x. If you want, like I said, divide. Well, 4 times 1 is 4. Now I got to subtract. And now you see what I was trying to tell you before. The remainder is negative 2. Okay? So we might write, if we were doing this kind of math, x plus 4, a remainder negative 2. The remainder equals negative 2. And how would you actually write that out? You'd write it out like this, but that's not the kind of math we're actually doing. Okay? And we don't have to worry about this kind of math, but that's what happens. So now you see that just like if you took two random numbers, like 7 and 22, if you divided them, see there's the number 3 that goes, but you're going to get 3 remainder 1. If you take random polynomials and you divide them, usually you're going to get a remainder. It's only occasional that you won't get a remainder. So I made that point. Keep it in the back of your mind that when you're doing this kind of math, if you get a remainder and they ask you to divide, you know you made a mistake. But does it happen? Most of the time if you randomly choose polynomials. So we briefly addressed that. I want to make sure that it makes sense what I'm talking about, because I keep saying it has to be like this, it has to be like this, but maybe it isn't. What does it look like? And then I want to make one more point about the problem that I just did. And what I really was doing here, by the way, is dividing. Hold on a second. I was dividing x squared plus 5x plus 2, or whatever it is, by x plus 1. Now, it's x minus 1, x plus 1. Now, you'll see a lot of that later. In fact, I'm going to put it in that form later. So take a good look at what I just did. I'm showing you your future, okay? And this is saying the same thing as that. So you divide this into that. So I'm just making a little configuration for you there. Keep that in the back of your mind because that's going to come up big time. All right. So anyway, let's move on real quick here. And now, for the first time, I'm doing a slightly more complicated problem, and I demand that it works. It's just a matter of how do you do it. Is it Regents level? Yeah. How far do they take it? I guess it depends on your math teacher and what they're stressing. So let me put this over here. And my task now is to divide this into this. And what's the difference from the problems we did earlier? Well, now there are 4 terms. There's this is a polynomial to the 3rd degree, and we go on. And I'm going to divide this now, and I'll check my answer briefly. But usually, like I said yesterday, when a student or a teacher gets remainder 0, they feel pretty confident that they can do it. So here I'll work through 1. It's the same math, it's just more terms. So how many times does x go into 3x cubed? Well, 2x squared. Work it backwards. Okay, this times this is x to the third. So I'm going to subtract that in a second, but I got to write down the second term here. Everybody see what I did? Okay, now subtract, and lo and behold, both of these guys go away. That doesn't always happen, but since we're focusing on easier problems here, in this case it does. So now what do? Is bring down the 3x, and x goes into 3x 3 times, and it happens to be positive, and 3 times x is 3x. I bring down the negative 6, I could have brought it down before, and 3 times negative 2 is negative 6, and when I subtract, there we go, whoops, this became negative, they canceled out in any case, that became positive, this was negative, and the remainder is 0. I do a quick check, move the thing over here, like I was doing yesterday, and try it on your own problem is similar to that. I'm going to do another one, but I won't check the next one because, like I mentioned before, students are generally very happy when they get no remainder, because what's really going on, as you can probably figure out, is that when you don't get a remainder, okay? Now, I want to point out that this expression here isn't completely factored. Does anybody see why? Well, the truth is, by the way, I'm putting this back together again. This is x to the third, and I'm just checking and putting it in its standard form, which you know all about. And I wondered if any of the students noticed that this should be factored. And you can do that here if I just take out the 3, and I have 3 times x squared plus 1. See how I factored out 3, and then times x minus 2. And that would be equivalent to this. I could do the same thing and factor the 3 out and get 3 times x cubed minus 2x squared. This is all going to be in parentheses. Plus x minus 2. And now you see all the terms of coprime. We had that, and this would be, for example, completely factored, and this would be the term to be factored. Okay? So how are we doing here? Let me do another one from last year's notes. And you will get, on your test, you will get a couple of questions asking you to do simple stuff like that. We're not going to take it to a big deal. I will give you an assignment with a couple of them, and I'll be doing the assignments maybe this afternoon or tomorrow, so you can get going on. I'll definitely assign you something on this kind of math, although like I said, the fourth homework was the same math. So here we go, and let me see what we got here. Yeah, we'll just do this one right here, and we need to divide 2x minus 3 into 2x cubed plus 6x squared. Okay, plus 6x squared minus, whoops, sorry about that. Got to get the data down right. Data's wrong in this math, you're dead. 2x cubed plus 3x squared. And I know this is taking a couple minutes here, minus 11x plus 3, but I wanted to do at least 2 before I give you an assignment. So we're pretty much guaranteed that if there's no mistakes in here, we're going to get a remainder of 0. I'm going to work top to bottom. I explained this to you before, so let's do it again. And this goes x squared times. Does the class see that? If you don't, you should extract 2x cubed and divide it by 2x. Okay? All right? You see what I did over there? So if you don't see it doing the opposite way, then just do the division skills with the monomial that you already have. And as you can see, these are equivalent. They're the same thing. And then x squared minus 3, so anyway, this by definition is 2x cubed. And then this one is a minus 3x squared. Okay? And we're making sure that we got all the terms down here correctly. Yeah. Okay? So now I take the opposite. This becomes a 0. This becomes 6x squared. And this is minus 11x. So 2x goes into 6x squared. See what I'm doing again? And that's 3x times. Everybody see that? Multiply backwards. Or extract this and divide it by 2x. Either way, you get the same answer. And then, of course, so let's multiply that back. So there I matched that. I had to do that. Otherwise, I'm not doing the math. And this is minus 9x. And that's an x as well. Okay, everybody see that? All right, I got one more term to do. So you see it's the same math. You're just subtracting polynomial math. So that's negative 2x plus 3. But if I look at this, I see I'm perfect on this. 2x divided by negative 2x is negative 1. If you don't see it, just do that. 2x divided by negative 2x equals negative 1 by definition. So it either works or it doesn't work. It either matches or it doesn't match. It's really that simple in that. So that's negative 2x when I multiply back. I'm going from here to here. And that's positive 3. There's the match. There's the subtraction. And there's the remainder. And I'll abstain from the check. You guys can do that one. And I'll give you some problems just like that you guys can do as an assignment. And then I'll try to wrap up everything tomorrow and move on in our math course. Okay? So I'll go over this. I don't think there are any mistakes. And I'll post it to you as soon as possible.